Let's look at this example and play around with units and interpreting the derivative. So let's let Q be the function f of p, and let Q give the number of pounds of sugar produced when the price per pound is p cents. So what are the units on Q, or rather the units on f? So this is the output, and it's giving us the number of pounds per sugar. So we will measure Q, we will measure f in pounds. And what are the units on units measuring P? P is the input variable, and it is kind of the price per pound here. It's being measured in cents. Okay, so what are the units on the derivative? So we can think about this as df dp if we want that notation, and we can remind ourselves this is similar to delta f over delta p. And the units on f we decided were pounds. The units on p were cents. So the units on f prime of p would be pounds per cent. Okay, so what does it mean to say f prime of 30 equals 50? Well, 30 is inside the parentheses. As a good reminder, we should think of that as the input. And the input for this function is p, and p is measured in cents. The output would be 50, and since this is a derivative, the units would be pounds per cent. Okay, so we've tackled the units, but what did this really tell us? We also notice that this is a positive 50, so that helps us understand maybe we could think about increase or decrease. Since the derivative is positive, we're looking at an increasing function. So we could say that when the price is 30 cents, the quantity produced is increasing at 50 pounds per cent. When price equals 30 cents, the quantity produced is increasing. So we could say Q is increasing at 50 pounds per cent. I think an easier way to help us understand what's going on is to actually play around with some wiggle room here. So if we maybe think about a line that represents all the inputs, we could do P as the inputs, and we could do F as the outputs. So P is being measured in cents, and F is being measured in pounds. What we're saying when we take a derivative is that if we fix a number, let's say 30, and we wiggle that a little bit, we move a little bit side to side, what does this change look like on the output? So we know that if we start at 30, we have some output value. We don't really know what it is. Well, let's just call this f of 30. But what happens when we actually do the movement? When we wiggle that 30, how does that impact the output? And so what we've got going on here, one way to think about this, if we nudge the input, say we increase it by 1, the output is going to increase by approximately 50 pounds. So we would know that this nudge should be a approximately 50-pound increase. So again, the derivative is saying if we have a little bit of wiggle room, if we nudge the input, what's the resulting nudge in the output? Well, the derivative says if we nudge the input, say about 1 unit, if we increase the price by approximately 1 cent, then the output is going to increase by approximately 50 pounds.